Hey everyone, I'm going to be going over the review for our upcoming quiz on quadratic functions, specifically involving imaginary numbers. So the first type of questions we have here, we need to solve these two equations. They're both equations that have radicals, or in other words, a square root, and they're set equal to a linear function. So if you remember when we looked at the graphs of this, we were looking at when a square root function is intersecting with a linear function. So we're going to figure that out algebraically by solving, and then we also need to check that if any of our solutions are extraneous at the end by verifying. So don't forget that part on the quiz. You will be asked to identify real and extraneous solutions. So in order to do that, you're going to have to verify, since you won't be able to graph the functions and you need to show work verifying in order to get full credit. I'm going to zoom in a little more to give some more space. So the first step with these, since the square root is by itself on the left side, the first step is always going to be to square both sides. So when I square the left side, that just gets rid of the square root and leaves me with x plus 2. I have to keep in mind to write kind of small here because these problems take up a lot of space. And then on the right side, I have x minus 10 squared, which is basically just saying x minus 10 times itself. Right. Our next step is to FOIL. So when we FOIL, or you might call it double distributing, we just have to make sure that we multiply every term in each binomial by every term in the other binomial. So x in the first binomial, x and negative 10, they need to multiply by x and negative 10 in the other binomial. So I start with just multiplying. If you use FOIL, I think of f as the first term. So I multiply the first terms in each parenthesis together first. So that gives me x squared. X times x gives you x squared, not 2x. Then the outer terms. So x times negative 10. X times negative 10 is negative 10x. Now the inner terms. Negative 10 times x. Once again, we get minus 10x. And then the last terms, negative 10 times negative 10 gives us positive 100. Now, if you're doing this correctly, you should always get these two common terms in the middle. Like, these should always be the same. The reason is because we're multiplying the same binomial by itself. So you're always going to get that middle term 2 times. So we're always going to have this next step of combining the like terms. So we have x plus 2 equals x squared minus 10x minus 10x. So that's like if you spend $10 and then spend 10 more dollars, you've spent 20 total. So it's minus 20x and then plus 100. I see a lot of people saying minus 10, something like that would be 0. It's not 0. If it's two subtraction signs, you're going to get a bigger negative number. Right? Now, we know in order to solve this, we're going to have to factor or use quadratic formula. So to solve this, we're going to have to get everything on the same side. So I'm going to subtract x on both sides. So that's going to subtract from the negative 20x. And then I'm also going to subtract 2 on both sides at the same time, which will subtract from 100. So I'm just doing that all in one step. So that leaves us with 0 equals x squared negative 20x minus 1x, if you want to think of it as minus 1x, is negative 21x. And then 100 minus 2 is 98. Now, this is the point where you could technically use quadratic formula, but I know that we can factor this. And on the quiz, you will be given something you can factor. So you can at least give it the factoring a shot, but if you really are a pro at quadratic formula and you feel like really terrible about factoring, then you can use the quadratic formula, but I'm going to factor. So I need to find what multiplies to 98 and adds to negative 21. So I'm going to make a list of factors for 98, and this is where obviously a calculator will come in handy. So I know 1 and 98 are my first two. And then you can divide 98 by 2 in your calculator, and you'll find that 2 and 49 are another set of factors. And if you keep trying to divide different numbers, you will also get that 7 and 14 are factors. And those are actually all the factors of 98. So I need to multiply to a positive but add to a negative. So that means that whatever I pick, both of the numbers are going to have to be negative. And I see here that the only ones that would add up to negative 21 are negative 7 and negative 14. So that gives me x minus 7 times x minus 14 equals 0. Now we get to use the zero product rule. So we set both terms equal to 0. So x minus 7 equals 0 and x minus 14 equals 0. And then we just solve both of these by adding. So we get x is equal to 7 and x is equal to 14. Okay, now do not forget the last step. You got to check for your extraneous solutions. And to do that, you're going to verify. So I'm going to verify over here on the left. I'll give myself a big box. So I'm going to start by verifying x equals 7. So to verify, I need to plug the x values back in for x in the original equation, not including this squared part that I added. That was just me solving. So I'm going to do square root of 7 plus 2 equals 7 minus 10. Then you just simplify the left side and the right side independently. Don't move terms to the right and to the left. Just simplify the left and simplify the right and see if they're the same. So I know that 7 plus 2 is 9, and 7 minus 10 is negative 3. And then I should see by now that it's going to be extraneous because the square root of something is not going to be negative. So because this is what we call the principal square root. It's saying it's asking for the positive square root of 9, which is 3, and that is not equal to negative 3. So I know that x equals 7 is an extraneous solution. I still want to check that 14 works though. This is also just a good way to check that you didn't mess anything up in your solving. So now I'm just plugging 14 in for x on both sides. Oops. So square root of 14 plus 2, that's square root of 16, and 14 minus 10 is 4, and I know the square root of 16 is 4, so that works. So x equals 14 is my real solution, and 7 would be my extraneous solution. Awesome, so let's go on to the second one. So again, same first step as before. The square root's by itself on the left, so I need to square both sides to get rid of that. So squaring on the left gets rid of the square root and leaves me with whatever's underneath, which in this case is x plus 6. 2x minus 3 squared, well, that's just 2x minus 3 multiplied by itself. So 2x minus 3 times 2x minus 3. Now it's time to FOIL. So, or double distribute. I'll start by multiplying the first terms together. So 2x times 2x is going to give me 4x squared. The outer terms, 2x times negative 3 is going to give me minus 6x. The inner terms, negative 3 times 2x is going to give me minus 6x again, which it should. Remember, as I said, these should always be the same because you're multiplying a binomial by itself. And then negative 3 times negative 3 is positive 9. set equal to x plus 6 still. Okay, so now take a moment to combine your like terms. X plus 6 equals 4x squared. Negative 6x minus 6x is minus 12x plus 9. Okay, so again, I know I'm going to have to either factor or use quadratic formula. So I'm going to go ahead and subtract x and 6 on both sides so that I can have 0 on the left. So if I subtract x from the x term, subtract 6 from the constant, that leaves me with 0 equals 4x squared. Negative 12x minus 1x, you want to think of it as 1x, will give you negative 13x. Remember, you can always do negative 12 minus 1 in the calculator if you are really wary about that. And then 9 minus 6 gives you positive 3. So now you could use quadratic formula, but I'm going to give it a shot. I'm going to give factoring a shot because I'm pretty sure this can be factored. So since there's a coefficient in front of x squared, we have to use the box method or factoring by grouping. And I need to start by multiplying my 4 times 3, which gives me 12. So I need to find something that multiplies to 12 and adds to negative 13. My factors of 12 are 1 and 12, 2 and 6, 3 and 4. And if it's multiplying to a positive number and adding to a negative number, then whatever I pick, I know that both terms have to be negative. Now, which of these would add to negative 13? That would have to be negative 1 and negative 12. So then I have x. Ooh, what am I doing? Got to make my box. So now I can set up my box. And if you have a different method, you know for this you can use it. Oh, my box is not even. Okay. So 4x squared goes in the first box. Positive 3 goes in the bottom right box. And then I use negative 1 and negative 12 to fill in my negative 1x and negative 12x. Because I'm splitting up the negative 13x into 2 boxes. Now here is where I need to do my greatest common factor. So I'm going to do the rows. So the greatest common factor of 4x squared and negative 1x, well, the greatest common factor of 4 and 1 is just 1, and then the least amount of x's is 1x. So I'm going to pull out an x. And then the greatest common factor of negative 12x and 3 would just be 3, because 3 goes into 12. But since this is a negative box, I'm going to pull out a negative 3, because you always want the negatives touching the negative boxes. Now I just need to think x times what would give me 4x squared. That would be 4x. And then x times what would give me negative 1x. That would be negative 1. And again, it's touching the negative box, so it should be negative. Now I have my factors. So I can set up 4x minus 1. Actually, I'll start with the 0 equals 4x minus 1 times x minus 3. And then I can solve this. So set each factor equal to 0. 4x minus 1 equals 0. X minus 3 equals 0. So I add 1 on both sides. 4x equals 1. Divide by 4. So x equals 1/4. And then over here, I just add 3 on both sides. I get x is 3. Now, don't forget our last step, which is to verify. This is going to be a little ugly because of the fraction 1/4, but you can just use a calculator. So if I plug in 1/4, square root of 1/4, I forgot I want to change my color. Okay. Square root of 1/4 plus 6 equals 2 times 1/4 minus 3. Now, for the left side, I would just put it in your calculator. Make sure you use parentheses in your square root, but you would get 2.5. And then 2 times 1/4 minus 3, again, you can just put it in your calculator, and you would get negative 2.5. So these are not the same. So 1/4 is going to be extraneous. And then the other solution we got was x equals 3. So we can verify that. Square root of 3 plus 6 equals 2 times 3 minus 3. Well, that would be the square root of 9 equals 6 minus 3. Square root of 9 is 3, and 6 minus 3 is 3. So that verifies that this is our extraneous solution, and this is our real solution. Just a note, I would not expect you to get a problem on the quiz where you have to use the box method, but it's good to still practice and remember it. You should be able to factor for this kind of a question, but technically you can use quadratic formula on these kinds of questions since you know it now. If you're really good at quadratic formula, but be careful because you can make mistakes with that too. Speaking of quadratic formula, we're going to do some examples. So if that floats your boat, this is a way you could have solved those equations at the top after you square both sides and get everything on one side. So we want to solve these quadratic equations using the quadratic formula, which will be given to you on the quiz. It will be given to you just like it is on your review. So you don't need to memorize it, even though you could using the awesome quadratic formula song. So for this first one, it's already set equal to 0, which is the first step with solving with quadratic formula. So now I just need to identify my a, b, and c values. A is always the value with x squared, so a is 2. B is always the value with x, so b is negative 11. And c is always the value, the constant value. So c equals 8. Now my next step is I always like to set up what I call my shell first, where I have just parentheses in place of all the letters. So I set everything up. This really helps me to make sure I don't mess up with any of the negatives. I don't put anything in my calculator wrong. If you're not setting up the shell and you're getting things wrong in your calculator, that is probably why. Because if you're not using the parentheses in your calculator, it's not going to calculate correctly. So now I just fill in each of my values. So I'll put B in orange. B is negative 11. A is 2. And C is 8. So I just plug them in all the right spots. Now I simplify it in 3 parts. I always simplify this part, the part under the square root, and then the part in the denominator. So x equals minus negative 11. A double negative becomes positive 11 in the first box, plus or minus the square root of. I need to find out what this in the box is. Square root of negative 11, or not square root, negative 11 squared minus 4 times 2 times 8. I'm going to do it in the calculator just to help you out. So I'm doing negative 11 squared minus 4 times 2 times 8. So again, here's where the parentheses become really important. Lost my screen. All right, here's how it looks. So I'm going to put exactly what I see to the right here in my calculator. Parentheses, I highly recommend you do this along with me. So this is not something that trips you up on the quiz because you'll lose points if you keep putting the calculator right. So negative 11 squared, or caret 2, you can use that too, minus 4 parentheses 2 parentheses 8. Oh. I got 57. All right, so I put a 57 under my square root. Some of you are trying to take the square root when you simplify this. You're going to have to round, and it's going to mess up the accuracy of your final answer. So just don't do it. Just simplify these 3 parts first. 2 times 2 is 4. Now this is where you will get your 2 different possible solutions. So x can be 11 plus root 57 over 4. And x can be 11 minus root 57 over 4. So now we can find out what those are in the calculator. I'll show you how to put this in correctly as well. So what I always do I do my numerator first, 11 plus second square root of 57, close the parentheses, enter. Then I click divide by 4. So I got 4.637. And then if I do my other one, I will do 11, now minus square root of 57, enter, then divide by 4. 0.863. So those are my two answers. I get 4.637 and 0.863. So those are your two solutions. Awesome. Now let's practice one more with the quadratic formula. So in this one, it's not set equal to 0 yet. So we need to start by setting it equal to 0. So I'm going to move my terms on the right over to the left side because I like to keep a number with x squared positive. So I'm going to subtract 2x on both sides, and I'm going to subtract 1 on both sides. So I get 3x squared. Negative 5x minus 2x gives me minus 7x, and then the minus 1 can't combine with anything, and that's equal to 0. So now I can identify what A, B, and C are. A is 3. B is negative 7. Remember, you always need to take the sign in front of the number with you. And then C is negative 1. So if there's a minus in front, then that means the value is negative. All right, so now I'm going to set up my shell. X equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2a. Also be very careful that your fraction bar extends all over everything and that your square root extends over this whole part right here. You have to be careful with that. It's going to be given to you, so you should be able to just double check that you're copying it down correctly. So A is 3, so I'm going to plug in a 3 here and a 3 here. B is negative 7, so I'll plug that in here and here. And then C is negative 1. This is a great reason why the parentheses are so helpful. If you did not have these parentheses, there's a really good chance you would forget to have the minus and the negative. And then your whole thing would be off. Because when we have a B that's negative, we end up getting a positive number in our first box when we simplify. So I'm going to find what the values in each of these boxes are to simplify. So x equals, again, minus negative 7. That's positive 7. So if you forgot the parentheses, you probably ended up with a negative 7 here, which would be a mistake. Now I need to figure out what this value is in the square root. So I'm going to use my calculator, and I'm not going to show it again because it takes too long. But I showed you exactly how to type it in. You should do the same exact thing just with these numbers, and you would get 61 under the square root, and then 2 times 3 gives you 6. So then I'm going to write out the two values I could get. I can get 7 plus square root of 61 over 6, and 7 minus square root of 61 over 6. Again, I'm not going to take the time to put them in the calculator in this video, but remember to do the numerator first, then divide by the denominator. After you click enter, you should get 2.468 and negative 0.135. And those are your answers. And remember, you can get 2 solutions, 0 solutions, 1 solutions, but we just practiced with finding 2 solutions, which should be sufficient to prepare for your quiz. All right, got one more question on this page. We're going to have to zoom out a little bit. No. Okay. So these are kind of like conceptual questions just to make sure you understand what I is. So So what numerical value does I represent? Is it real or imaginary? Well, remember we learned that I is equal to the square root of -1. It's not equal to -1 because that would be crazy if we suddenly came out of nowhere and said I meant the same as -1, which you've been using for years. I is the square root of -1. It's something new. It's something we haven't been able to define before. Now we can. And then I, since it's the square root of a negative number, that means it's imaginary. So basically, an imaginary number is anything that is a negative under a square root. That gives you an imaginary number. So since I is the square root of -1, it's an imaginary number. What numerical value does I squared represent? Is this real or imaginary? Well, I squared would be the square root of -1 squared. Well, when I square something with the square root, it just gets rid of the square root or undoes the square root and leaves me with whatever's inside the square root, which was -1. And I mean, -1 is a number we've seen around for most of our lives. So -1 is real. It's not imaginary. It's real because, yes, it originally had an I in it, but when you simplify it, you get a real number, -1. It doesn't have an I in it once you simplify it, so that means it's real. Okay? Whereas up here, you can't simplify this anymore to have something that isn't a negative under the square root. All right, on to the back. This should not take as long. Solve each quadratic equation. Your answers could be real or imaginary. Okay, so you can ignore the point values on this. I forgot to take that off. Did I do that on these other questions? No. Did I do that on the front? Okay, that was going to bother me. Whoops. All right. So to solve the quadratic equation, I'm going to start with looking at this first one on the left. And I see that x squared is in one spot, which means I should use the square root method. Don't try and factor something when you don't have to, right? And don't try and use the quadratic formula when you don't have to, okay? If you see the x in one spot, like if you can circle where the x is in one spot and you're not like circling half the equation, if you can circle that single x in one tiny circle like this, there it is, then it's by itself, okay? So that means you can use square root method. So basically you're thinking of a do-undo chart. I'm not going to make one, but if you want to, you can. The first thing you would do is subtract 5 on both sides. We're trying to get x by itself. So we get 3x squared equals -15. All right. Now, some of you like to say at this point that you can take the square root. That's not true because I cannot take the square root until whatever is being squared is totally by itself. And 3 is not being squared because there's not parentheses around 3 and x. The only thing being squared here is x, and I cannot take the square root until that is by itself. So I need to divide by 3 next. So I get x squared equals -15 divided by +3 leaves me with a -5. Okay, here comes the part where we get to take the square root. Favorite part. Now remember, when you take the square root, you got to do the plus or minus square root. Okay, so on the left side, taking the square root just leaves us with x. On the right side, now we have plus or minus the square root of -5. Do not stop here. You will lose points because now that we know about I, we should simplify this. So we know that I represents the square root of -1. Since I see a -5 inside the square root, think of it as this is the same as plus or minus. Oh, this is a mess. I'm going to zoom in a little more. All right, since there's a negative in the square root, think of it as plus or minus the square root of -1 times 5. That's pretty much, that's the same as the square root of -5. So I get to take the -1 out because I know the square root of -1 is I. So plus or minus I. and then the 5 is left underneath. And I can't take the square root of 5, or I don't know what the square root of 5 is. It's not an easy number. So I'm just going to leave it under there. So that means my answer is plus or minus I root 5. I like to write it out separately. So I'm going to write x is positive I root 5 and x is negative I root 5. Since there are i's in our final answers, these are imaginary solutions. You don't have to write that down, but I just want to make sure you knew that. All right? Because you could get a real solution for these problems. All right, next one. So again, think of a do undo. If I can circle x, it's right there. There's no other x's. That means I can use square root method. So I'm going to add 7 on both sides. That leaves me with x plus 6 squared equals 25. Now I get to take the square root of both sides already. The reason being that everything inside the parentheses, x plus 6, is being squared. If everything that's left is being squared, then I can take the square root. And I have plus or minus square root on the right side. So that gets rid of the square on the left. So I have x plus 6 equals plus or minus, the square root of 25 is 5. Now, x is still not by itself, so we're not done. This is where I make my two equations. X plus 6 can be positive 5, and x plus 6 can be negative 5. And I need to do my last step to solve, which is to subtract 6 on both sides. So x is negative 1. Subtract 6 on both sides. X is negative 11. So this time I got 2 real solutions. They're real because there's not an I, there's not a negative under the square root. Last one. First step here would be to subtract 10 on both sides. That leaves me with negative 4, x minus 2 squared equals 64. Now I can't take the square root yet because there's still something outside the square root that I have to get rid of, which is negative 4. So I need to divide both sides by negative 4. I'm left with x minus 2 squared equals, when I divide 64 by negative 4, I get negative 16. Positive divided by a negative is a negative. Now that I'm left with everything being squared on the left side, I can take the square root of both sides, plus or minus square root. Don't forget that plus or minus. Then I'm left with x minus 2 equals, I'm just going to copy this whole thing, plus or minus square root of negative 16. I like to take things in steps. Now I'm looking at this and I know that if I see a negative under the square root, I'm supposed to do something with I. We should know that. So I'm going to leave the x minus 2 on the left side, plus or minus. I'm going to copy all that down, and then I'm just going to simplify the square root of negative 16. Well, I know from before that if there's a negative under the square root, I take it out in the form of an I, and then I would be left with square root of 16. I also know that the square root of 16 is 4. So that means I'm going to have I times 4. So in other words, I'd rather just write plus or minus 4I. I times 4 is the same thing. It just looks a little nicer when you write it as 4I. So now, just like before in the problem over here to the left, now we have 2 equations because x is still not by itself. So x minus 2 is equal to positive 4I, and x minus 2 is equal to negative 4I. So I just have one more thing to do, and that's add 2 on both sides. And 4I is an imaginary number. 2 is a real number. So I can't combine them. I'm just going to leave it as x equals 4I plus 2. I cannot combine them because one is real, one is imaginary. Same thing over here. I get x equals negative 4I plus 2. So really these kinds of problems, it's just, don't let it stress you out because it's really just combining what we already know about square root method and what we now know about imaginary numbers. It just, instead of at this step saying, oh, we have no solution, we continue, we simplify it to have an I, and then we still, add 2 on both sides. It's just, we can't actually combine the real and imaginary numbers, so we end up with something that just looks a little different. All right, let's go on. We are going to simplify these expressions using what we now know about I. So when I see an expression that has a negative under the square root, I know that I can take the negative out in the form of I. I'm going to remind you about y. If I see the square root of negative 81, that's the same as the square root of negative 1 times 81. Those are the same thing. And since I know that the square root of negative 1 is I, then I'm left with square root of 81. Okay, I take the I out because I know the square root of negative 1, and then I leave it as square root of 81. So that's why I can do that. So now that I know that, I'm going to say, okay, I have a 3 times square root of negative 81. Well, we just found that that's equal to I root 81. So I pulled the negative out in the form of an I, and then it's being multiplied by 3. Well, I have one more thing I can simplify. I know the square root of 81 is 9, so this is really 9i. But lastly, I know I can multiply a real number with an imaginary number. Before I was explaining you can't add them together, I can multiply them because I can take the real part of I, I'm going to use a different color, the real part of this number and multiply it with the real number, and I would get 27i. All right. All right, here I've got parentheses, I square root of 15, parentheses squared. I'm emphasizing the parentheses because the fact that the squared is outside of the parentheses means I'm going to square both the I and the root 15. So when I square I get I squared. And then when I square a square root, I just should end up with whatever was inside the square root, which in this case is 15. So I squared times 15. Well, I have my really important fact, I'll write it in red up here, that I squared is equal to negative 1. I would just write that at the top of your paper, honestly, when you get the quiz, because you don't want to forget it. I squared is negative 1. This is not fully simplified. Since we know I squared is negative 1, we need to change it. So that means we have negative 1 times 15. And that would give us negative 15. All right, this next one, we do not have any parentheses. That means the only thing being squared here is I, not 7. So I'm going to keep the 7. And then I know I squared, I just talked about it, is negative 1. 7 times negative 1 is negative 7. Sorry, I switched between using parentheses for multiplication and using the dot. It really doesn't matter. You should be able to tell that I mean the same thing either way. So I get negative 7 here. All right, let's go on. All right, this one, slightly different, but it's really similar to what we do with real numbers. Actually, it's exactly the same. 2 is multiplying the quantity of 4i plus 9. So I need to distribute the 2 to both parts of the inside of the parentheses. So 2 times 4i would be 8i. We just talked about how you multiply the real parts and then keep the I. And then 2 times 9 is plus 18. 8i plus 18. That cannot be simplified at all because we cannot add a real number with an imaginary number. Right here we have two imaginary numbers being subtracted. So it's kind of similar to when you have like 10x minus 3x. You just subtract the 10 and the 3 and then you keep the I. So 10 minus 3 gives you 7i, or 10i minus 3i gives you 7i. You just take the real parts, 10 minus 3, subtract them, and then keep the common I. Think of it as like terms. Like when we have a like term that has an x and a like term that has an x, you just combine them like this. Last one. This is probably the trickiest one. So since we see two binomials, even though they have imaginary numbers, we do have to double distribute or FOIL. So I'll start by multiplying the first terms. 7 times 2 is 14. The outer terms, 7 times negative 5i. I'm going to take the real parts, 7 and negative 5, multiply them. So I get negative 35, and then I can't forget the I because it's 7 times negative 5i. If I do the middle terms or the inner terms, negative 3i times 2, that would give me negative 6i. And you're not going to get the same number here and here because we're multiplying two different binomials here, in case you were thinking that. So negative 3i times 2, multiply the 3 and the 2, and then keep the I. And then the last terms, negative 3i times negative 5i. Well, I know the negative 3 times negative 5 will give me plus 15, and then the I times I will give me I squared. So I have a little more simplifying to do here. One being that these are like terms, so I can combine them. 14, negative 35i minus 6i will be negative 41i. And then here, I know that I squared is negative 1. So I actually have plus 15 times negative 1, which is just 14 minus 41i minus 15. And I have one more set of like terms, 14 and negative 15. I can combine them. 14 minus 15 is negative 1, and then I have minus 41 times I. And that's my answer. All right. That is probably the hardest kind of one of those questions. All right. So I need to determine if each expression is real or imaginary. Well, I'm just going to quickly simplify each one and then see if I have an I left or not. I know 6i plus 6i, that's going to be 12i, and there is an I left here. So this one is going to be imaginary. I'm just going to write I am imaginary. Negative 3i squared. Well, the only thing being squared is I, and I know I squared is negative 1. Negative 3 times negative 1 is positive 3. So that means I have a real one because 3, it doesn't have an I in it, so it's real. Square root of negative 5. Well, honestly, you don't even have to simplify this. You know if you have a square root of negative, it's imaginary. But if you wanted to, you would get I square root of 5. And so that would mean it has to be imaginary. Last one, negative 2i times negative 8i. I multiply the real numbers and the imaginary numbers. So negative 2 times negative 8 gives me positive 16. I times I gives me I squared. I squared is negative 1. So 16 times negative 1 is negative 16. So I do end up with a real number here. All right, last question. Circle all of the expressions that equal negative 12. Well, okay, I'm just going to go through and simplify each one the best I can. This first one, notice that the negative is outside the square root. So we don't have anything imaginary here. This is just a normal expression. You're very used to it. I know the square root of 144 is 12, and then I just carry down the negative. So this one is equal to negative 12. 3i times 4i, well, that's 12i squared. And then I squared is negative 1, and 12 times negative 1 is negative 12. So this one is equal to negative 12. 14i minus 2i, that would be 12i. I can't simplify this anymore. If I had an I squared, like I did over here, then I would get negative 12, but this is just an I. So this one is not equal to negative 12. Here I do have a negative under the square root, so I can simplify this. I have an I already on the outside, and when I simplify my square root of negative 144, I should get I square root of 144, which is just I times 12. So I times I is I squared. I squared times 12. I squared is negative 1, so you do get negative 12. So this one's equal to negative 12. Last one, again, I already did this over here, but I take the negative out as an I, and then I simplify the square root of 144 to 12. So I get 12i, which is not equal to negative 12. All right, that's everything. I'm going to stop this video because I think it's pretty long. Good luck.